Have you ever wondered how surgeons deal with massive wounds, the kind you get from really severe burns or a major accident? Well, often, the solution is this incredible surgical procedure that literally uses one piece of skin to create a life-saving patch for another. Today, we're diving deep into the world of split-thickness skin grafts.
All right, so here's our game plan. We're going to start with the basics, our amazing skin, then talk about when it needs serious help. After that, we'll get into the skin graft itself, walk through the actual procedure, and then explore the fascinating biology of how it all heals. We'll wrap things up by looking at the success rates and the super exciting future of wound care. Let's jump in.
So, before we can even begin to talk about fixing skin, we have to understand what we're working with, right? And our skin, well, it's not just a simple covering. It's a complex, multi-layered, and frankly, brilliant organ.
First up, you've got the top layer, the epidermis. In simple terms, think of it as your body's personal waterproof raincoat. It's our frontline defense against everything. Now, for the medical side, it's a super thin layer of cells, mostly keratinocytes, that form that barrier, and melanocytes, which are the cells that give our skin its color.
And right underneath that raincoat is the real support structure, the dermis. This is what gives your skin its strength and its bounce. It's made of a tough, fibrous mix of collagen, which provides the toughness, and elastin, which gives it that flexibility. And, critically, the dermis is where the blood vessels are that feed that outer layer, the epidermis. Now, our skin is amazing at healing on its own, we all know that, but sometimes the damage is just too much. It's too big, too deep, and that's when surgeons have to step in and give it a helping hand. A skin graft isn't for your average cut or scrape. We're talking about the big stuff. It's an absolutely essential tool for treating huge wounds from major burns or trauma. It's used for those stubborn chronic ulcers that just refuse to heal, or to close up large surgical sites. Basically, anytime a wound is just too big for the body to close on its own, a graft becomes a real possibility. And that brings us to the hero of our story today, the split-thickness skin graft, or, as you'll hear it called, the STSG. So what is it exactly? Well, a split-thickness skin graft is a procedure where a surgeon takes the entire top layer of skin, that's the epidermis, and just a portion of the deeper dermis from a healthy spot on the body, which we call the donor site. Then, that sheet of skin is moved to cover the open wound. The key word here is split. We're not taking the full depth of the skin. Okay, now this is a really important distinction. With a split-thickness graft, because you leave some of the dermis behind, the donor site can actually heal on its own, kind of like a bad scrape. But with a full-thickness graft, you take all the layers, so that donor site has to be stitched closed. That's a huge difference. Full-thickness grafts are often saved for areas where cosmetics are key, like the face, while split-thickness grafts are the absolute workhorses for covering really large areas. And this is exactly why STSGs are so incredibly valuable. The fact that the donor site can heal up and even be used again. That means surgeons can cover massive wounds, like on a severe burn patient, in a way that would be totally impossible otherwise. The ability for that donor site to heal up in just a couple of weeks is a real game changer in reconstructive surgery.
Okay, so we've covered the what and the why. Now let's get into the how. What actually happens during the procedure?
The whole thing is like a carefully choreographed dance. First, you have to prep the wound, cleaning it down to healthy, bleeding tissue so the graft has a good foundation. Next, a special tool called a dermatome is used to shave a paper-thin layer of skin from the donor site. That graft can then be meshed, we'll talk about that in a sec, to expand it. Then it's carefully placed, dermal side down, onto the wound, secured in place, and covered with a protective dressing.
So why would you mesh a graft? Well, it's a brilliant piece of surgical engineering. By putting tiny slits in the skin, you can stretch a small piece to cover an area up to 6 times its original size. It also lets any fluid drain out from underneath. The trade-off, though, is the final look. It can leave a sort of cobblestone or net-like pattern. An unmeshed graft or a sheet graft looks much smoother and more natural, but you can't cover nearly as much area. It's a classic case of function versus form.
And now for the part that I think is just mind-blowing, the biology. We've just moved a piece of living tissue from one place to another. How on earth does it survive and actually become part of its new home?
You see, here's the critical challenge. When that graft is first laid down, it has zero blood supply. It is completely cut off. Its entire survival depends on its ability to get food and oxygen from the wound bed below it and eventually to grow all new blood vessels. This process is called neovascularization. It's a desperate race against time.
And that race happens in very distinct phases. For the first day or two, the graft literally drinks plasma from the wound bed, just soaking it up like a sponge to stay alive. The medical term for this is imbibition. Then, around day 2 or 3, something amazing happens. The tiny blood vessels from the wound bed start to connect with the old vessels in the graft. It's like they're linking up. That's called inosculation. By about a week in, the graft is fully attached and has its own blood supply again. But the full healing process, the maturation, that can take over a year.
So the big question is, how well does all this work? And what's on the horizon? Let's get into our final section on outcomes and what's next.
Just take a look at that number, 70 to 90%. That's the typical success rate for split-thickness skin grafts. When you think about how complex this whole biological process is, that is an absolutely incredible success rate. It's really a testament to both surgical skill and the amazing resilience of the human body.
Of course, it's not without its risks. The biggest enemies of a brand new skin graft are things like fluid building up underneath it, infection, or any kind of movement, surgeons call it shear, that can break those fragile new blood vessel connections. These are the things that the medical team works so hard to prevent.
And as amazing as skin grafting is, as much of a pillar of surgery as it's been for decades, the future is already knocking on the door. Right now, scientists and doctors are looking for ways to heal massive wounds without needing to create a second wound at a donor site.
And this is where it starts to sound like science fiction, but I promise you it is happening right now. Imagine growing sheets of a patient's own skin in a lab from a tiny biopsy. Or what about a device that literally sprays your own skin cells onto a burn to heal it? We're even seeing the very beginnings of 3D bioprinting to create personalized skin layers. This isn't a movie. It's the cutting edge of regenerative medicine.
Which really leaves us with this one big, fascinating question. We've gone from borrowing skin from one part of the body to heal another, to the very real possibility of just creating new skin on demand. So the question really isn't if this will happen, but how soon will this incredible technology make the whole idea of a donor site a thing of the past?